protocol observed. As already introduced, I'm Christine Betty Nagao from the Department of Forestry, Biodiversity and Tourism, Makerere University. I'm happy to be here again to present something on what we are doing on environmental pollution and mitigation, including plastics and microplastics. Pollution is not a new word, but you find that these days we are placing more emphasis on environmental pollution. How are we contaminating our ecosystems? We have different chemicals, we have different byproducts. All these end up in the different forms of the environment. Let's say be it air, the soil, and water. So all these are the sources of contaminants within our environment, and this is what we want to consider within as we look at this presentation here today. So I tried to list the different types of pollution. We have air pollution, water pollution, soil pollution, plastic pollution, which is our point of emphasis today, because you find that here very many plastics are in production, and usually they are ignored, because you find that when you look around us everywhere, at least in Kenya, I could say your environment is friendly in terms of plastic waste management. But if you came to Kampala, what is going to welcome you are the littered plastic of different forms, the plastic bottles, the polyethylene, the PVCs, everywhere, that even when we have our different policies to try and manage them, these plastics are still a challenge to us. And that is why you find that here we are trying to find ways in which we can deal with these plastics. Of course, what is also maybe could include here is the noise and thermal pollution. Usually there are different, let's say, businesses which need to advertise their businesses almost all the time. So you're creating a lot of noise which is ignored. But you find that here their cumulative effects may have an effect on our health, and then also the ecosystem in which we are living in. So what are plastics? We find that here, these plastics, as quoted from here, Zia et al., they're a group of materials that have infiltrated and they've become part of our lives. Almost from the time you wake up to the time you sleep, you're using some form of plastic. There is nothing we can do about it, that if it has become part of us. But you find that here, most of this plastic is synthetic. And we know that most of these synthetic substances are not easily broken down. So they're always going to remain within the environment. And if we try to look at the population, the production of plastics is competing with the population on Earth. Because if each person, every day, let's say you're drinking water from a plastic bottle, then how many bottles are going to end up within the waste, within the environment? Because you find that sometimes we have no waste collection centers, so they are going to remain there. And you find that even when these plastics end up in the landfills, we are either burning them or recycling them. If we burn plastic, what are the different byproducts? They have very many additives. Some are toxic, while a few are non-toxic. While burning may look like a solution, you find that the products are going to be harmful to the plant, the wildlife, and then certainly the humans, because we are interacting with them more and more. So what we need to think about, if I'm using the plastics, then how am I going to manage them so that they don't end up within the environment or within the different ecosystems. So here, this graph just shows us the increase in the production of plastics over years. If we look from the 1950s to where we are, that was in 2020, 4 years ago, we find that every year, or let's say every year, the plastic production is increasing. If in 2020 we were at 367 million metric tons, that was in the COVID era, where we are saying that production was a bit slowed down. What do you think that the position is now, 4 years later? So you'd find that here, you'll find that we could have produced more plastic, but where is this plastic going? So what are we going to do about this? If we are looking at the packaging, we've just been given a bag. I don't know if it is biodegradable, because you find that here, even when we change the form in which the plastic is going to be found, you find that it is still going to remain as plastic. So is it going to break down easily, or we are only encouraging the reuse of the plastics that we are producing these days? So if we compare that in 2020, we produced 387 million metric tons, and only 9% was plastic. Where did the other percent of the plastic end up? So you find that here, this 79% is going to remain within our landfills. But you find that here, more so, this is going to, of course, continue disrupting the different economic activities that we are doing, which is also automatically impacting the human health within our environment. So this is just a picture showing the situation in Kampala. This is one of the, as we know, Kampala is our capital city in Uganda, but to try to find out what are the sources of plastic contamination within Kampala. So you can see how it looks. We have a plastic collection site, we have a washing bay and a repair site, we have a solid waste dump area, and then of course we also have a wastewater treatment plant, and you can also see here a settlement area within the Nachibumbo channel, which automatically means that waste at any one time is going to end up being directly discharged in the environment. So if you're to pass through such a scenario, and this channel is to help in the filtration of the water which is going to end up being used, it would mean that our life is at stake, because it's not going to be safe at all because of the accumulation of the plastics that we are producing at any one time. So we also have here an example of a landfill. We are saying that most of the plastic is ending up in landfills. In these landfills, we expect this waste to be taken care of. Here we are seeing a truck which is helping to, let's say, to turn the waste in order to burn it. And then you also find that here, because buying of plastic is a business these days, even when some few people are employed to collect the plastic, you find that this is not enough. In Kampala, we haven't yet reached a stage where the plastic, let's say, is going to be turned into smaller components. So you find heaps and heaps of plastic within these landfills. Recently, there was a landslide at the landfill. I don't know if any of you heard about it. Many people lost their lives. It happened very early in the morning on a weekend where most of the offices are closed. And people had to fight for their lives. A few lucky ones escaped while others were covered in plastic. Even when people talk, the government is yet to see the importance of managing these landfills. Because even if we collect the landfills, if we remove the plastic from the population, but end up not managing it well, you find that here it is still going to have an effect on the people within these different environments. This is showing the aftermath of the landslide within where the landfill is located in Kampala, in Uganda. So when you look at such a scenario, of course, it would automatically mean that these plastics are going to have an impact on the environment. We know, of course, they're persistent. Plastics can remain in the soil for very many years without any degradation. Of course, they are a constant source of pollution because they're going to litter the land, of course, leading to large-scale pollution. As we have just seen at the landfills, chemicals leach into the soil and the ground water, which chemicals find their way into the water bodies, which our people are using for their subsistence. If we look at the marine ecosystems, where more research has been done compared to our water bodies, you find that we still need a lot of time to work on the management of our plastics. Of course, once our wildlife or even the domestic animals we keep ingest these plastics, some of them are ending up dying because once they enter into the bodies, they're going to suffocate the animal, which will end up dying. And finally, they're breaking down into microplastics, into smaller sizes. So these microplastics are invisible to the eye, but you find that here, when you look at them, they are going to have an effect still on our health. They are used like the plastics, the macroplastics. You find that although they are less than 5 millimeters in size, you find that most of them are being added to, let's say, the different products that we are using, the detergents, some pharmaceuticals, and very many, let's say even the toothpaste. They want to improve on the texture of the products that they're producing. So they end up using adding these small plastics, and of course they're going to end up in the environment. So different studies have been carried out, and so far some animal studies have shown that these microplastics, once they've been absorbed, they're distributing themselves into the different parts of the body. There's also a story or an article online where a group of scientists from their research, they are saying that microplastics have been found in the semen of men. So, and also in blood. So if we have these microplastics within us, what is happening to the what? To the next generation. So we need to start to look at this. And then they're also transporting the persistent organic pollutants. So we are moving from the lower trophic levels to the higher trophic levels. If we look at each of these, or within the different forms, you find that here we need to act very fast to try and deal with these plastics. Microplastics are classified into different forms. We have the primary microplastics. So when during production we are producing emissions, we are producing dust from plastic to give us our primary microplastics. Then when we look at the secondary microplastics, these ones are product of weathering, and then the nanoplastics, they're also products of fragmentation and weathering. So if it is of a nano size, it is going to actually pass through most of the, let's say, the devices we could decide to use to try and remove these plastics. So if you're doing a water purification process, because they are of that size, it would mean that these nanoplastics are going to end up with the end user at the end of the process. So what are the most common effects that we could say? We have the water environment, the marine and fresh water, the aquatic life and its biodiversity, of course human health, since there are chances of bioaccumulation of these microplastics, and then they're also, we are ingesting them as part of our life, and then through the air we breathe, the microplastics are present, so they're also ending up within our lungs. So if these microplastics are part of us, how are we going to deal with them? The best solution, of course, is to stop the production of plastic. If we say that we are stopping the production of plastic, what is going to be the alternative to this plastic? Because you find that here, it's like this plastic is needed in almost all aspects of life that we are dealing with. So this is just a figure which was adapted from Kiran et al., which is showing the different areas where the plastic or some of the effects on the plastic. When you break down, when we produce our plastics, as you can see here, we have our plastic bottles. Degradation can occur from the sunlight. It could be oxidation and then biodegradation. So on fragmentation, we are producing the microplastics. And you also find that here, if we look at an example of the landfill, through leaching, these plastics are ending up into the river, lakes, and other water bodies. And also find that here, if you also look at the other side, we could take an example of industries which are producing the car tires. If you're driving car, sometimes it is too hot. So there is going to be some friction between the tire and the surface. So we are producing small particles of those rubber tires, which are also becoming part of our runoff. So we are not safe, I could say, we are not safe anymore, because almost all the processes that we are handling are producing microplastics, which microplastics are also leading to the different effects that we are seeing within the different areas of the environment, let it be aquatic or within the terrestrial environments. So I included some bits of research that we are doing. We are investigating some of the occurrence of microplastic contaminants into Lake Victoria through Nachivubo Channel. Nachivubo Channel is one of the points which have been put in the city to help and collect the stormwater after a runoff. But you find that its management has not been the best. So where are we going to do? So in a bit to find out if microplastics are really present within the water, one of the students, of course, when we are collecting the plastics, when we are dealing with plastics, you have to use a material which is different from the plastic, and that is why we are using a stainless steel bucket. We collect the water from the channel, filter it, and then after filtering, of course, we are using glass bottles, because if you're using a plastic container, then it would mean you're already contaminating the water. So once filtration is completed, we store the water in a dark area in order to prevent effects of light from degrading the plastic within the environment. So this is followed by filtration, and of course when you're dealing with this, most of the times you have to ensure that we are using plastic gloves, but it is going to be single use. Because if you move from one container to another using the same glove, you're not sure whether the next sample you're going to touch is going to have plastic on it. And also to ensure that we don't have any contamination, usually as we work, we have water within a glass container just to see if there has been any plastic or microplastic that has been absorbed into the water during the duration of the experiment. We have to separate them using different chemicals, and then we have to visualize the plastic using a microscope. This is, and here this was at the point when we had already finished filtering and visualization of the plastic, and then we do the characterization using FTIR at the Department of, or the Government Analytical Laboratory, to try and ascertain the type of plastic. Because when you look at it through a microscope, you're not going to tell if which type of plastic it is, but at least you can identify that maybe these are their plastics or microplastics present within the environment. This is just the characterization for the microscope. This is what you're going to look at. And of course, under the microscope, you have to count each of them individually, because these microplastics are of different forms. It could be a film, it could be a fragment, and then also form. And then you also have to that you're not using a wrong identification. Sometimes we also perform what we call a hot needle test. If it is a plastic, you find that it is going to respond to the heat, but if it is just a piece of cloth, you find that the heat is not going to have any effect on the plastic that we are using. So this is just a summary of the different types of the plastics from the different sampling sites. We had what are called fragments, films, granules, filaments, and foam, which were collected within our study areas. S3 is a washing bay. So when you take your car for washing, what are some of the byproducts that are going to end up discharged within the water bodies? That is why you find that here, the percentage, we have very many filaments present within that particular area. So we also try to compare the wet season and the dry season to see if they have any effect on the increased accumulation of the microplastics within the different areas. So this is just a summary of all the water samples. We can see here that the filaments were the most common type of microplastics that were present within the collected samples there. So this is just a summary of the different shapes within the samples that we are collected, and you can see that most of the filaments are coming either from the textiles, from when you wash your clothes, there are some filaments that are breaking off. Of course, we also have fishing being done. We are using plastic nets, and then of course the waste water. This effluent is passing through the different areas within the city, which is going to affect also, or which is going to end up within the different sources where the waste is being collected within the different areas. So this was just at the, using an FTR spectra, we have a standard which compare with our sample. We don't want to identify let's say the polyethylene wrongly. So we have to be sure that during our characterization, the standard and the sample, for us to confirm that it has polyethylene, our spectra patterns should be more or less the same. So from here, we could see that effluent from the different businesses surrounding the channel are one of the sources of the microplastics within the environment. There are also this accumulation within the wet season and the dry season. At least we could see that within the wet season, we are having a higher percentage of microplastics within the environment that is causing the variation between the different seasons. You also find that here, in the areas where we have the wastewater treatment plant, the effluent had low amounts of microplastics, which is a good thing. At least the process is trying to get rid of some of the microplastics, which would end up in the water. Our studies were also in agreement with one of the studies by another scientist, Kalkoza, who found filaments as one of the most abundant type of microplastic within the water. We could also say that these are among the most common, because if you look around us, the polyethylene and then the polypropylene, that is the most common form of plastic that is being used within the different areas. And as long as we look at the catchment surrounding our lake, you find that here we should take all the necessary steps to stop them getting into the drainage system within the different areas that we are working with. We also considered another study where now we are looking at fish, because you know that fish is a delicacy, like also in Kenya, and wanted to see if these microplastics are also ending up in some of the fish within the lake. So these are the 3 fish that we used, and we are looking at the different levels within our trophic chain. If we have the omnivores and then the carnivores, if I'm feeding, let's say, on phytoplanktons, how is it going to affect the fish in case some of these fish are going to feed on the other? Are they going to transfer their microplastics from one level to another? So this is just a summary of what is being done. Of course, we have to remove, we fillet, and then remove the gills with just using potassium hydroxide, add zinc chloride to help in the density separation, which is going to be followed by microscopy. We want to visualize to identify if there are microplastics present, and then we go to FTIR spectroscopy to actually identify the form of the microplastic that is present within the sample that we are dealing with. So from this, at least when we look at the whole samples and the muscles and gills, so far we didn't find any microplastics, which was different from the GIT. You find that here there are high amounts of microplastics for the dry season. And this is just a variation. If we are looking at the location and season, the number of microplastics that were present, the dry season, and then also the wet season. So here, KCS usually is acting as our control because it is at least far from the settlements, or we refer to it more as a rural area compared to the other sites, the Port Bell, and then the Ripon Falls, which are close to the communities where we expect that the use of plastics is at a higher level, of course, which would affect how the plastics are going to vary within the different areas. So we also try to look at the different color of the diversity of the microplastics in the gut, because when we looked at the muscle and the gills, we didn't find any microplastics. But when we look at the gut, maybe at the time of harvesting of the fish, the microplastics were yet to move into the muscle of this fish that we are actually looking at within the different areas. So this is similar to what was seen in the catchment of the water samples, where we are looking at just the gut content to see the different forms. The good thing is that each of the microplastics has got a distinct form, such that it becomes very easy for you to distinguish it from another without let's say, misidentifying it within the different forms that you have found it within the different areas. So this is still also the same. When you try to group them according to the sizes, you find that most of them were lying within the range of 0.3 to 0.9 millimeters, which is also still within the range in which we are saying here that these microplastics varying within the, let's say, the wet season and the dry season, how they're going to vary across the gut within the different species of the fish. This is similar to confirm the plastic that you're talking about. Before we want to avoid any misinformation when you are dealing with the identification of these microplastics. So far, the conclusions, this has been repeated. At least we haven't yet seen any evidence of biomagnification and possible trophic transfer. Maybe we could say under high exposure, but we are still, this is not conclusive. We are still trying to do pyrolysis, GCMS, to see if the results are going to be different, to see maybe if what we could not identify using the FTIR from the GCMS, we can be able to identify these microplastics within the different fish, within the different environments. So far, some of the recommendations, at least the law should be amended if there are any violation of plastic policies, Of course, we need to increase public awareness and motivation. We are either going to encourage the use of biodegradable bags and then non-plastic materials. Or if you're using the non-plastic materials, let's stay away from single-use plastic. We can use the plastic as many times as we can before it can end up as waste. A policy framework to emphasize the management of plastics. And then, of course, we should set standards for design and provide security for end markets. If we look at the circular economy, we need to reuse, recycle, and then sometimes we need to also recover some of these plastics. You could also refuse to use plastic. If you come to a conference and you're given water in a plastic bottle, you can refuse to drink. You can refuse to drink the water because that would mean that is one bottle less in the, or one source of waste in the plastic. So we need innovations in the products that we are going to use. If you're using a bag, it should be, if we can't stay away from the plastic, let's buy a biodegradable bag. That way we can be sure of what we are using. We could also look at some ways of mitigation of the plastic pollution. Of course, first of all, we reduce and eliminate the single-use plastic. If you're drinking a soda, you don't need to use to drink the what? The soda. Clean the bottle properly, and then you take your soda. That is, of course, we shall have reduced. We need to do improved waste management. I don't know how it is working in Kenya, but at least in Uganda so far, waste management is still a challenge. So if someone can come up with an idea, we could start a collaboration to see how we can deal with the problems of waste management in Uganda. We could look at innovative materials. It could be biodegradable. It could be a more sustainable alternative, or we can use bioplastic, which we are sure is going to degrade more quickly. Of course, legislation is going to be important. Like if I can take the example of Uganda, plastic use has been banned. But what is happening, while they are banning use of plastics, they are also encouraging a certain micron size of plastic to use. So you can't ban one and then you say when you increase the microns, we can use the plastic. We have done nothing because we are still producing the same polythene bags which are going to end up within the environment. Then advanced filtering, where we upgrade the wastewater treatment such that we are sure that the filters we are using can even remove those small sizes of plastic within the water that we are using. So another way that we can look at in mitigating plastic pollution is what we are calling the nature-based solutions. So nature-based solutions are just options to address the different threats to the environment. It could be in terms of climate change, biodiversity loss, and environmental degradation. So when we look at the different ways of sustainably managing and restoring our ecosystems, then you find that here we shall be on the right path. For the case of plastic solution, we could look at our example. We know that wetlands act as natural filters. So if they can trap the plastic waste before moving to the water bodies, this would be very helpful. And then we could also look at if we are to manage the plastic, we could do the recycling and incineration. And then, of course, we need to replace our plastics with sustainable alternatives. We could also look at bio-based polymers, which are produced from, these are going to reduce our dependency on the fossil fuels. They've started manufacturing the polyhydroxyalkanoates. These, we are using microorganisms which are being synthesized by bacteria. So I would like, the bio-based polymers, those ones we shall be sure so that we can move to the different areas, so that the management of plastic is going to start with you. I would like to thank Kenya Chemical Society for the invitation, and I would also like to thank the different collaborators we are working with, and of course our sponsors. Thank you for your kind attention.
Thank you very much, Dr. Christine. I think she's covered a lot of the plastics. Maybe I just want to request that maybe we can ask a few questions, and just to ask one from my side. I don't know whether it's possible, but do you think we can do without plastics in the whole world?
No.
We can't. So at some point we cannot eliminate plastics.
Yeah, we just need to manage them properly.
Okay. Thank you. That is the question I wanted to ask, because I'm actually having plastics all over me now. Yeah, so the platform is open for questions to Dr. Christie's presentation. Maybe one or two questions directed to Dr. Yes, Prof.
Thank you very much. I think that's a very good presentation. But probably you could consider the fishes. I'm in fisheries, so I'm very conversant to the topic level. And in Victoria, probably you are looking at the fish that does not reflect the food web adequately. You probably need to look at the conservator as an fish. And then the pyramid of numbers and biomass would probably suggest that you look at the paradigm, the streams, the social streams, in terms of biomass. I think it forms a very critical link in the food chain. And of course, then you have not sampled the plankton, and the plankton is the base of the food web. So probably that will give you very good indications of the biomagnification and bioaccumulation. I'm very curious about the nanoplastics, and if they can pass through the cell membrane, then this will be a very serious risk in terms of human health. As you know, we end up eating the fish, and with biomagnification, this can be quite unhealthy. So probably we also need to get permission to look at nanoplastics in human beings. I don't know how to do that, but probably to the blood some other drugs. Thank you.
Thank you. Can I address some concerns to address? Or are they just points to us?
They are just points of consideration.
Good. Thank you for that, Prof. Any other questions? Yes, George.
Thank you. Thank you so much. I also appreciate the presentation and just wish to request that kind of review. There is something about bringing back the flags. This is a project that was done by some students in Western Washington University, where I come.
Any other questions to her? Okay, yes, Prof. Okay, that's a question for you to think about. Any questions or inputs? Maybe you can address that, Dr. Christie.
Yeah, like I said, we say that people are either incinerating the plastic or they are recycling. But you find that here, they are not aware that burning plastic is producing toxic chemicals within the environment. So unless we are going to, let's say, burn the plastic in a controlled environment where we can collect the fumes that are being produced, we find that here, burning the plastic is still a hazard. This is an health.
Yes, Doc? Or are you Prof? Okay, Prof, go
No,
first.
I just want to respond to Charles. I think what should be done, because we remember we have the biomass. So the pipe that Prof is talking about is actually falling into the biomass. And the biomass now, the major usage of the biomass is now to produce energy. So that way, even the plastics will fall there and they'll be used controllably. Of course, we'll have people here and there, but mostly not in the developed world. The developed world is just not burning. When we talk about biomass, we actually talk about the developing world. So that's where we put things elderly. But of course now, there is that emerging technology that we now use the biomass to generate energy, whether it's electricity, whether heat, anything, all those things. So that's why I think thank you.
Thank you, Prof. Maybe Dr. Joseph?
Yeah, thank you so much for the presentation. One of the methods we used was hot needle to check swelling. I don't know, do you, in the experiment, were they also doing white peroxide to remove anything that
Yes.
could be,
Yes.
okay, and the heat were left with fiber?
Yes.
Were you able to identify which plastics are most common for most AIR?
Prof?
Your FTIR?
Yeah, the profiling,
Yes.
I told you it is. Because of the motion.
P, yeah?
Yes.
Still P. Thank you so much. I appreciate it because I have a PhD student who just finished work on that.
Yes, thank you very much, Dr. Kristen, for the presentation. And maybe now I want to request that we have a brief photo session outside, and you'll be directed where we're going to have the session, and then we come back for tea. Tea will be taken just inside the room. You just come in walking, take what you feel like, and then sit with it in your place where you're seated. So kindly we can maybe walk out and have the photo session.